Quadratic formula word problems. You have a regular pen constructed using one side of the house as the side of the pen. Thick lines the side of the house. You have 100 feet of fencing. So this plus this equal 100. These two sides are the same, so I'm just going to call those x. So just to find the bottom side, we know it's 100 all the way around the three sides. So if I take 100 and I subtract those two sides, I will get the remaining side. Okay? X will be greater than 0. Okay? You know that has to be a positive number. And also, the 100 minus 2x is also greater than 0. Okay? So x is greater than 0. So x is greater than 0. If you take this and solve it, move the 2 over, 100 is greater than 2x, divide by 2. You have 50 is greater than x, or x is less than 50. There's the x is less than 50 part. So x is between 0 and 50 somewhere. Area of the pen, remember, is length times width. The length and the width, x, and 100 minus 2x. So I multiplied it out, and then I put it in the order ax squared plus bx plus c. And then remember, if you draw this out, it's a parabola. Remember, the maximum or minimum point is at the vertex. This is a parabola that opens downward if you drew it. So it gives me a maximum at the top of the parabola. Okay? So the maximum happens, x is equal to the opposite of b over 2a. Opposite of b is opposite of 100 over 2 times negative 2. 100 over negative 4 is 25. So the maximum happens when x is equal to 25. So the maximum happens when x is equal to 25. And that is 25. So I have 100 minus 2 times 25. 100 minus 2 times 25 is 100 minus 50. So this is a 25 by 50 pen. 25 by 50 pen will have the greatest area. So the area, you could take 25 and plug it into this equation or this equation. It doesn't really matter. This is probably easier, 25 times 50. When you multiply it, you get 25 times 50, what I said there, which is 1,250 square feet. Next one. Manufacturer has 100 tons of a product that he can sell now for a profit of $5 per ton. For each week he delays shipment, he can produce an additional 10 tons. Unfortunately, for each week he delays, he decreases his profit by 25 cents a ton. When should he ship to maximize his profit? And what is the maximum profit? So I'm going to say let x be the number of weeks to delay. So right now, that would be not delaying, so time would be 0. At time 0, I would have 100 tons, it says, at a profit of $5 per ton. So to find my total profit, I would just take number of tons times the profit, and that would give me $500 profit. If I delayed 1 week from now, I wouldn't have 100 tons. I could do an additional 10 tons, so I would have 100 plus 10, or 110 tons. My profit, though, wouldn't be $5. It decreased by 25 cents. So if I take 110 times 475, that'll give me my profit. And you can do that until you see a pattern. You know, if you don't see a pattern yet, try 2 weeks from now. 100 plus and let me write this differently. 100 plus, if I do 2 times 10. And my profit decreased by 2 times 25 cents, or 50 cents. And if I multiply, I have my new profit. And this one, think of it as 100 plus, I delayed 3 weeks, so I can make 10 tons extra per week. And there's my profit and the total profit and so forth. So if I do, this is 1, 2, and 3 weeks, if it's X weeks, it would be 100 plus X times 10, or 10X. And my profit would be 5 minus 25 cents times X. And if I multiply the two, that'll give me my total profit. Okay? So if I multiply those two and I FOIL it, first, inner, outer, last, you'll have 500 minus 25x, because you have, sorry, hold on. Minus 25x plus 50x gives you plus 25x. I combine like terms. And your last ones would be negative 2.5x squared. Or, I want to put the x squared first. There it is. So the maximum happens when x is equal to the opposite of b over 2a. The opposite of b is 25, negative 25, over 2 times negative 2.5. So I have negative 25 over negative 5, which is 5. So the maximum happens x equals 5. X is equal to the number of the weeks I delay. So I want to delay 5 weeks. And if I delay 5 weeks, my profit will be, plug in 5 into your equation. And when you plug in 5 into your equation, you get $562.50. Next page. This is the last page. State whether the quadratic has a maximum or minimum and a value x, which a maximum, and what the value is that the maximum and minimum occurs. Remember, if it opens upward, it'll have a minimum. If it opens downward, it'll have a maximum. Okay? This right here opens, you should know which way, upward. So the value of the maximum happens when x is equal to the opposite of b over 2a. So the opposite of negative 8 over 2 times 1, which gives me 4. Okay, so that's the x-coordinate of the vertex. If I wanted to find the y-coordinate of the vertex, I would plug 4 into the equation. Doesn't matter which one. This equation here, it's a negative x squared. So it opens downward. So that one has a maximum. This one had a minimum because it opens, and did I write it anywhere? No, I don't think I did. This one opens upward, so this one has a minimum. This one opens downward, so this one has a maximum. And the maximum happens, I don't even have to use the equation for this one because it's the x-coordinate of the vertex. 2 is the x-coordinate of the vertex. Did I write it anywhere? I don't know if I wrote it anywhere, but I'll write it here. There. C. The opposite, or opens upward. So it has a minimum. Opposite of B, so 6 over, what's 6, whatever 6 is, over 2a. 2 times 2 is 4. So 6/4, 3/2. The next one, negative, it opens downward. X is the opposite of B, so 4. 4 over 2a. A is negative 3. So 2 times negative 3 is negative 6. So 4 over negative 6, which would be negative 2/3 when you reduce it.